Hey, pre-calculus, let's go over Unit 2, Lesson 8, and let's make our homework answer key. All right, so yeah, today's our first day working with rational functions and seeing the properties that they have. Let's jump in. Okay, so it says the rate at which people enter an exhibition hall. Okay, whatever, it's this function, all right, 8600 divided by t squared, where t is measured in hours after midnight, okay, and e of t is measured in people per hour. So e of t is measured in people per hour. So we got hours after midnight, people per hour. The function is valid for 7 through 12. So what is this? Hours after midnight. So this is from 7 o'clock in the morning to 12 o'clock noon is when it's valid from. They're saying that because the function's going to do its own thing, and they're saying that the part of the function that we care about that actually does fit a normal day situation is that. Okay, so they're cutting it off, which represents the 5 hours that the exhibition hall is open. Great. Explain why e of t is a rational function. Well, this is a monomial, and this is a, well, trinomial. These are polynomials, and it's because we have two polynomials being divided by each other. I'm not even going to write that down, but we have two polynomials being used in this, a polynomial on top and a polynomial here. Great. Find e of 10 and interpret the value. Okay, well, so this is calculator work. So we're going to be doing 10, putting it in for t, that we're going to square it and get 100, and then we're going to subtract from that 10 times 20, which would be 200, and then we're going to add 180 to that, 180, and then we're going to divide that. Yeah, okay, let's just do it. 8600 divided by 100 minus negative 200, so yeah, negative 200 plus 180. Yeah, I know. Let's just do it. We get 430, so we get a value that is negative. Oh, that's not right. That's not right, because 100 minus 200 is, yeah, minus 100. I combined that incorrectly. 107.5. There we go. So what the heck does that mean? 107.5. So what does it mean constant? So we were putting in a 10. That means 10 a.m. So it means at 10 a.m. As people are entering this hall, they're entering at a rate of 107.5. They said it here, people per hour. People per hour. Wow, so all right, whatever. All right, let's move on. The horizontal asymptote, find the horizontal asymptote for each function. This just kind of comes back to the notes that we looked at, so that's what I'm going to refer to. It's all about the degree of the function. Let's go ahead and just like look at those numbers here. So we got, let's see, I got a degree 2 and a 2, and I got a, let's see, a degree 1 and a 2, and I got a degree 4, and I got a degree 3. Great. All right. Oh, let's look at this. Find the slant asymptote of this one. Ooh, all right, that's going to be fun. Anyway. Okay, the powers are equal. The powers are equal. Okay, so when the degree of the functions are equal, the degree of f and g are the top and the bottom are equal, the horizontal asymptote is equal to the ratio of the leading coefficients. The ratio of the leading coefficients of 3 and 8 is y equals 3/8. That is the line, the horizontal line at 3/8. It's less than 1, it's more than 0. That's the answer. Okay, so here, the bottom has a higher degree than the top, or we would say the top has a smaller degree than the bottom. Then that's a horizontal asymptote at y equals 0. See how fast that type of question is. Here, the top one is higher than the bottom one, so the top one is greater than the bottom one. It's not going to be no asymptote, because it's actually this one. The degree of the top one is 1 more than the degree of the bottom one. It's a slant asymptote. We're going to divide by them, ignore the remainder, and the linear factor we get is the, okay, let's do this. So, oh boy, do I really have to do it, doesn't it? Oh, no, yeah, it's great, it's greater, but it's greater than by 1. My gosh, it's greater than it by 1. I'm looking at this, I'm looking at the answer key here, and it says it doesn't exist, the degree of the numerator is greater than the degree of the denominator. Yeah, but it's greater than it by just a factor of 1 here. So I kind of feel like we should do the, yeah, we should do the long division. Write this out as, let's see, 5x to the 4th plus 4x to the, I don't have enough room. Okay, I am going to have 2x to the 3rd minus 12x plus 1 gets divided into 4x to the 3rd plus 5x to the 5x to the 4th, 5x to the 4th plus 4x to the 3rd, and then we would have no x squared and a no x and a minus 2. Okay, so let's see, to turn this into a, my gosh, that's why, that's, yeah, here's the thing, is as we divide this in, we're going to get a linear factor up here. That's going to, yeah, so I don't want to do this. How do we turn a 2 into a 5? Well, we multiply by 2.5x, okay? And we multiply this by 2.5. Oh my God, I don't want to do that, but we get 5x to the 4th. Oh my gosh, and 2.5 times 12, blah, 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 blah. So 12 times 2.5, ugh, all right, 30. They're 30, but it'd be a negative 30x times x. Would that be an x squared? Oh my God, negative 30x squared. There would be nothing here. We would be subtracting these. Oh my gosh, that's nothing. We'd have a 4x to the 3rd and a minus 30x squared. Oh no, man, we got this 1x. Oh man, and we have this, oh my God, and then a 1 times 2.5 would be a 2.5x. Again, I don't want to do any of this, but anyway, we're gonna, yeah, we're dividing this in. My gosh, 2 plus 2. So, yeah, 2. That would work for that. Now, we're gonna get a remainder with this. I'm not even gonna continue forward with this. That would be our linear factor. I want to look into this one. So 2.5x plus 2, y equals that, is what I think the asymptote would be. It's either that or it doesn't have one. I'm going to type this into Desmos later and kind of find out and see if I need to like update the answer key or if that is the horizontal asymptote. Let's do this one. All right. So looking at this, it's like, can we want to find the slant asymptote for this. We're told that there's a slant asymptote. That's because the degree of this and this are off by 1. This is going to be a long division problem. Holy moly. Just like what we're doing. We're doing x to the 3rd plus 2x squared minus 4x. I love that at least all the terms are here, plus 8, and there's no zeros. We got an x squared minus 7x. Oh my gosh, plus 1. We're going to have to multiply by an x. Great, thank you. X times x squared makes that x to the 3rd minus 7x squared and plus x, but we are subtracting all of that. So that goes away. There's a 0. 2 minus negative 7 is like adding 7. We get 9x squared, and negative 4 minus x would be negative 5x. Okay, and then bring the 8 down. Bring the 8 down. Great. Whew. Oh, this is not right. This is not right because I had a missing term that was in here. My God, I hate myself sometimes. All right, but anyway, let's move on with this. I need to turn 9x squared, or x squared into 9x squared. I got to multiply by 9, a positive 9. That's my linear factor. I honestly don't need to do any more than that. Our linear factor, or slant asymptote, is going to be at y equals that. Okay, done. The rest of this would just result in a remainder. Okay, the directions on a can of orange juice concentrate say to add 3 12-ounce cans of water to 1 12-ounce can of orange juice. Oh my gosh. Irmgard thinks that regular orange juice is too sweet, so she likes to dilute it with water. Suppose that X ounces of water are added to the pitcher of prepared juice. If the orange juice is made according to the package instructions, what percentage of the pitcher is concentrate and what percent is water? Wow. Wow. Holy moly. Oh my gosh. My brain was not prepared for thinking through this one. I'll be honest, folks. I'm skipping 3. Let's move on. Okay. I want to focus on ones, yeah, ones like 7 and 8 here. So let's see. 7. The graph of the rational function h is shown. Which of the following statements is true? So we got a vertical asymptote. It seems like there's a horizontal asymptote somewhere in the mix here. Okay, so which of the following is true? The degree of the numerator is less than the degree of the denominator. Well, let's see what we got. So as it looks like I can't quite tell. I can't quite tell if this is hitting 0 here. But here's the thing. We've got a slant going on. That's a slant asymptote. So what does a slant asymptote mean? It means that the degree of the numerator is 1 more than the denominator. Okay. Let's see. The degree of the numerator is exactly 1 more than that's the one. C right there. That's the answer for that one. Yeah, let's move on. 8. So we got 8. Which equation could represent this graph? Well, see that we have a horizontal asymptote that doesn't quite seem like it'd be 0. We got 2 vertical asymptotes. All right, and so we're gonna have two zeros here, 2 things that it can't equal that are zeros. So let's look at this. All right, we got this 4x plus 5. Let's see, these are off by 1. So if the top one is less than the other one, we'd have a y-intercept at an asymptote at y equals 0, horizontal asymptote. This one, they're equal, so it's going to be a horizontal asymptote at y equals 2 divided by 1, y equals 2. This is top heavy. Top heavy, but it's off by 1, so this would have a slant asymptote. Yep. This one is bottom heavy. All right, so the degree is less than. We'd have a slant asymptote y equals 0. Okay, so we can absolutely rule this out. When I look at this, I'd want a little more evidence. This is seeming like this is the asymptote somewhere there. So we're going with that one. This is going to be 2, y equals 2, not 0. Okay. Write an equation for a rational function that has a horizontal asymptote at y equals 4. So, yeah, we're going to have, so has a horizontal asymptote at y equals 4. So if it's going to be y equals a number, then the degrees are going to be equal, and we want the ratio of them to be. So here's the thing. We're going to have like I don't know, y equals, x to the what? X to the 7th? You're welcome. All right, over another x to the 7th. Toss in some plus or minus stuff in here. All right, go ahead, toss in some terms. 8x squared minus 5, I don't know. Doesn't really matter. Doesn't matter, because all that matters is that the ratio of this to this is 4. So I could put a 12 here and a 3 here as the leading coefficients. 12 divided by 3 is 4. I could put an 8 and a 2. There's an infinite number of possibilities, but that's what I'm looking at. I'm looking at these 2 powers are the same, and I'm looking for the leading coefficients to be to have a ratio that's equal to 4. All right, that's it. This was a smaller homework because, I'm also choosing to not do the other problems that didn't match up with what we did in class. Take care, folks. Bye.